Okay, so we will solve a set of review of previous problems. I sent you the problems on the group. Okay, let us start with the first one. In this problem, you have a skier start from rest at the top of a frictionless incline of height 20 meters, as shown in the figure. At the bottom of the incline, he encounters a horizontal surface where the coefficient of kinetic friction between the skis and the snow is 0.21. Determine how far she traveled on the horizontal surface before coming to rest if she simply costs to a stop. So in this problem, you have first a surface that is not perfectly linear, and you have motion on a curved path, تقريبا like this. Okay. And then at the bottom, you will reach a smooth surface. مش smooth surface. The surface is horizontal but rough. Okay. يعني هون you have rough surface but horizontal. And here you have curved surface but smooth. So here is curved and smooth, while at the lower level it's rough and horizontal. Okay, now they told us that the height here is between the top level and the horizontal line is 20 meters. The inclination of the angle of inclination here is 20 degrees. And the initial velocity, the skier starts from the top at v equals 0. The question is to find what is the total surface, the total distance moved on the horizontal part before coming to rest. So here again, at this point here, the velocity again will be 0. Okay. And the friction of the coefficient friction is given to be equal to 0.21. It's a kinetic friction coefficient. How can you solve this problem? What should we use?
مش وين فيز ولا فيز واحدة؟
فيكم تعملوا فيز واحدة، فيكم تعملوا 2 بدكم اياه، بس انتم اعملوا الاسرع طريقة. شو هي اسرع طريقة؟
نعملها فيز واحدة ونستعمل
لانه هن طلبوا مني شيل velocity هون. لا, they didn't ask for the intermediate velocity, so no need to do 2 steps. You can directly apply. يعني إذا بعتبر 1 2 3, I can directly apply from 1 to 3. Okay. فينا أعمل conservation of mechanical energy here?
Nope, لأنه في rough surface.
Exactly. So we have losses, so we cannot apply conservation. Then we'll apply work and energy. Okay. So work and energy. Okay. So between directly, we'll apply it between 1 and 3. Okay. So work and energy between 1 and 3 directly. So we can state that the initial kinetic energy is 0 plus sum of work of forces between points 1 and 3 equal to the final kinetic energy, which is also 0. So we can deduce that sum of work is 0. Okay. What are the forces doing work from 1 to 3?
في عندي الويت.
Okay.
The friction.
Weight will friction. Okay. Normal at any stage, the normal is perpendicular to the path. So if you illustrate the free body diagram at any point on the downward motion, you have the normal and you have the weight. Normal will not do a work, only the weight. So the weight will only do a work from 1 to 2. Will it do any work from 2 to 3?
لا لأن بتصير
لا لأنه from 2 to 3 if you draw the free body diagram you have the normal, you have the weight, and both now are perpendicular to motions. They will not produce a work, so you have the friction. The friction force from 2 to 3 will do a negative work. It will oppose motion, while from 1 to 2 the weight will do a positive work because we go down. Okay, so in total we can write that. What is the expression of the work of weight? Between 1 and 3, what is the expression for the work of weight?
مش mg8
okay 20? mg times what?
times the distance.
شو هي distance?
20.
طيب وال 20 degrees بشو بعوزها هون؟ هيدي الانجل بشو بعوزها؟
بقول انه sin 20 equal 20 over distance تبعت المشية.
لا هيدي تريك بليز، مش على طول، مش على طول لازم تستعملوا كل شيء. اوكي سو هون عم يعطوكم هالانجل جاست تيغلبطوكم. I don't need it. Okay, I just need the difference in height. لو كانوا عاطيني distance هيك I need it then, because if they give me, if you want the total inclined distance d, then I say to find the variation in height I do d sine 20. But because they already gave me the difference in height, I don't care for this angle, so I will not use it. انتبهوا. اوكي في منهم بيغلطوا انه في هذا انجل يمكن لازم اعمل sin 20. No, I will not need it. So it's a positive work because I'm moving down. Okay, so plus mg times 20, which is the variation in height. This is the work of weight. Now concerning friction, the friction will do a positive or negative work?
A negative.
Negative.
And what is the expression of its work?
Mu km
minus, okay, mu k times n times what? مش بس mu k n. mu k n بتعطينا الفريكشن، بس we should multiply the friction by what to get the work?
times distance.
Very good. The distance هيدي المطلوبة. The only unknown is the distance traveled before stopping. صح؟ Now we want to find this distance d here. The distance traveled before coming to stop at point 3. Okay, so I still need to get n. What is the value of n?
Be equal للweight.
Exactly. So انتبهوا ال n بخدها بالفيز between 2 and at point 3. يعني أنا between 2 and 3. يعني حيلا point here it's a constant. Pay attention. لو normal variable between 2 and 3, I cannot write minus mu k n times d. If n is variable, then I should integrate. I should find how n is varying with position, and I should integrate to find the work. But since at any location between 2 and 3, the free body diagram is the same, and the normal force is always equal to the weight at any point, then n is a constant. So I can just replace n by m times g, because in y I have equilibrium, and the only force opposing the weight is the normal, so n should be equal to w. And then if I replace now in my equation, the only unknown is what? Is the distance. So I can say that the distance traveled is equal to mg times 20 over, and you will see that mg will be simplified. This is why they didn't give you the mass. Okay, so it's over mg times mu k. Okay, so now we simplify m and g, and then we get that the distance is 20 over mu k, and we have the value of mu k, so we can get the value of the distance. Okay, now can you give me another method to get d, different than using work and energy? Who can give me another method to get this distance?
معقول فينا نعمل sum of forces نجيب acceleration بعدين نجيب
yes very good. بس we need كمان an extra step. شو هي؟ يعني فينا نجيب deceleration إذا بدك between 2 and 3. It will be a constant value. Okay, so let me erase here and draw it again. So I can use a second method. If they ask me to use the Newton law in my computation of d, I can say that during this path of motion here, my forces are, so this is d, my forces are the normal, the weight, and the friction. Okay, and now I have to find the value of A. So I can write, so if this is my x direction, I can write that sum of forces along x equals to max. And the only force along x is the friction. So minus F equals to max. Now, as we did already, the friction is mu k times n, and n is equal to the weight because of the balance along y. So I can write minus mu k times n, which is mg, is equal to m times a. Now, m will be simplified, and then I can deduce that the deceleration is equal to mu k. Okay, now we know that for constant a, I can relate the distance d and the final and initial velocity of the phase. I know that the final velocity is 0, but I need then to get the velocity at point 2 to be able to proceed. Okay, so I can write that velocity at point, this is point 3, velocity at point 3 square minus velocity at point 2 square equals to 2a times the displacement, and the displacement is equal to the distance d. Now v3 is 0, the acceleration is minus mu k times g. Okay, so I replace a by its value, so minus 2 times a times mu k. Sorry, instead of a, I will put mu k g, and I multiply by the distance. And then to be able to get d, I need to know the value of v2. Okay, so I still need to do an additional step, but I can find v2 in a very simple way. How can I find v at point 2? What can I use? Which formula? Who can give me the value of v2?
Energy between A and B.
Yes, conservation of mechanical energy between 1 and 2. If you apply conservation of mechanical energy between 1 and 2, okay, then you have you can take your reference of gravitational potential energy here, okay, and this distance is given 20. This distance h is equal to 20. Here you can directly use this result when you only have the effect of weight, okay, and we'll derive it now together. You can say that kinetic energy at point 1, which is 0 because it's starting from rest, plus the gravitational potential energy at point 1, which is m times g times h, okay, equals to, at the final state, what is 0 now is the gravitational potential energy, because this is my reference. So mgh will be equal to half m v2 square. So you can directly use this result if you just say conservation of mechanical energy, then gravitational potential at 1 equal kinetic energy at 2. And I can get that V2 is simply, if I simplify the mass, then V2 is just equal to radical 2gh. Okay. And now all you have to do is to replace back into your equation. Okay, so here V2 square is 2gh, so you get the following: 2 times g times h, okay, is equal, the minus and minus will give you plus, is equal to 2 times mu kg times d, and again you will reach the same result. Okay, so mu k times g times d. G will do 2g will simplify 2g and 2g, and again you got back to the same result, that the distance is h over mu k. اوكي
مدام بس سؤال اي متى بياخذ الويت على انه نفس النورم؟
اي متى شو؟
اقل على بعض، الويت اقل على الان
لما يكونوا ما في غيرهم forces واثنيناتهم بالvertical direction. يعني انت if you take حسن any point here when going down، اذا بترسم الفري بودي diagram النورمال perpendicular to contact منا vertical، صح؟ والويت vertical، فهون ما حيطلع n equal w، وعندك الفريكشن لورا إذا في friction. يعني إذا ما في friction عندك just n و w. In this case, okay, to get n, what should you use? كيف فيك تجيب الإكسبريشن ل n when you go down? Who will tell me how you can get the value of n as you go downward?
From the vertical component of W.
No. Why no, Teresia? It's Teresia.
Mm-hmm.
Why no? Tell me, Teresia. Do you have equilibrium in this direction? Look, you are moving on a curve. When you move on a curve, keep in mind that you have a normal acceleration and a tangential acceleration. If it was a straight line down, and if you are moving on a straight line that is inclined, then you have sum of forces 0 in which direction?
Oh, okay, sorry.
Okay, so you can say then, in case this is a straight line, you say I will project on y, this is y, no motion along y. So the value of n will be balanced with the projection of the weight on what? On the perpendicular to the incline. And I consider this is, let me change the color. Along this line, which is perpendicular to motion, I don't have any motion. So acceleration is 0 along this line. Okay, since this is a straight line motion, not a curved motion. So when you project here, the weight projection should balance n. So in this case, to find, you should know the angle here. let's say this angle is alpha. Okay, so the angle between the weight and the perpendicular to the incline will also be alpha. And then you say sum of y equals 0 because no motion along y. And then you have plus n minus w cosine alpha equals 0. Okay, and this will, yes, this will allow you to get n. But in case you have curved motion, which is the case here, and here if you look at the figure I sent you, it's not a straight line, it has curvature. Whenever you have curvature, this means that your acceleration is not restricted to the direction of motion. Your acceleration will be divided into two components. One that is tangential along ut, and another one along un. So it will depend on the curvature. Let me erase a little bit to have a clearer drawing. If you have this, okay, if you take, for example, a point here, the radius of curvature will be from this side, so un will be like this. If you take a point, for example, here, it's opposite. So when you do analysis at this point, the radius of curvature is from the other side, and then un is like this. Okay, so at each point of interest, you should draw your free body diagram. So let's say you are interested what is happening at this position. The normal is along un. The weight is always vertical. And now what you will use to get n, which formula?
Sigma of n equals to MAN.
Yes, very good. Sum of forces along un equals to MAN. And to get AN, you need to know the velocity. Okay, to know the velocity, all you need is to know the height here. Yani, what is the height? You can then use work and energy to get V. Okay, so if I tell you what is the level of this point, you know this height, the difference between the initial point and this one, you apply conservation of mechanical energy, you get V here. And once you get V from a conservation of mechanical energy, you can replace into AN. So it's mv squared over rho. They should give you the radius of curvature. Okay, they will give you here, for example, that will tell you that rho is equal, for example, to 10 meters, for example. So you can use it to find AN. And then when you project on AN, you have the normal plus n minus, if we should know the angle here, alpha. So minus W cosine alpha. So we obtain a similar relation if you want, but now with it's not equal to 0. You know why for a straight line is 0? Because what is the radius of curvature for a straight line? When you have a straight line, the radius of curvature is at infinity. So if you replace here rho by infinity, you get back to the relation for a straight line, which is n equal W cosine alpha. Okay. Any other question on this?
بس في عندي سؤال صغير.
Yes.
كان عندنا وقت ألفا equal 20 degrees بس ما حطينا ساين 20. أنا ما استوعبت كتير إنه ليه.
أوكي. لأنه أنت وقت تعلمنا نحن الويت work بالwork of the weight. شو كانت الفورمولا؟ you remember شيء؟
mg
okay, minus mg delta y, exactly. والy is in axis that is vertical. وقت نحط minus mg delta y, y axis is vertical upward. okay. طيب حتى logically فكر منطق، الويت بيأثر على عنده work is I have a horizontal displacement or only it's producing work because of vertical displacement. إذا بتتذكر وقت حكينا عن ال work of a force، كان a force do a work if it's perpendicular to motion in the direction perpendicular to motion.
لا.
لا، بس بقدر اعمل work اذا عندي motion بالdirection، اذا عندي component of motion بالdirection of the force. الweight is vertical، يعني انت اذا بتعمل horizontal displacement ما بيعمل work الweight، بس حيعمل work when you do any vertical displacement. فانت بهيدي when you move on this curve you don't care for the displacement along x. You just care only for the vertical displacement, and this vertical displacement is already given for you. هن قالوا لك إنه vertical displacement is 20 meters. Okay, so do you need to know anything else to know the work of the weight? ولا بس بهمك change in y?
change in y.
So you don't need this angle, you don't care about it. أي متى معقول عوز الانجل؟ إذا بدل ما يعطوني this distance قالوا لي إنه this this distance is given. يعني لو قالوا لي مثلا إنه هيدي distance دي is given وما عطوني 20 meters، I have to compute what is delta y, and then delta y is, so if this is delta y in this right triangle, I can write that delta y is d sine 20. Okay, so هون بدل ما يعطوني d عطوني دغري delta y. So this is why giving me the angle is not useful, and they just gave it to me as a trick to see if I understood how to find the work of the weight or not. Okay.
بس هلا مثلا بس نعمل الفورمولا الأساسية ما بتكون نعمل projection للأنجل، يعني بتيجي من ورا الدلتا واي. ما هيك؟
مظبوط، بس ما انت مظبوط، انت انتبه على شغله، انت الورك اوف ويت فيك تلاقيه بطريقتين، فيك تلاقيه بالماينس ام جي دلتا واي، او فيك تعمل بروجكشن للويت على الدايركشن اوف موشن. بس هون بما انه it's a curved motion it's very complex to calculate. يعني اذا بتتذكر بس اخذنا example of inclined motion straight، كنا نقول تنجيب الورك اوف ذا ويت عندنا تو بروسيجر، او بنستعمل ام جي دلتا واي يعني بس بنهمنا نجيب الديستنس هيدي، او تاني strategy is to project the weight. يعني if you have the weight like this you project it on the direction of motion. Okay, when you project it on the direction of motion it's downward, and the magnitude تبع البروجكشن اذا هيدا الفا البروجكشن بتكون mg sin alpha. Okay, and then you multiply by d. يعني من بعد ما تجيب البروجكشن of the weight you multiply by the distance of displacement، ساعتها بتاخد head distance so you multiply by d. اثنيناتهم بيعطوك نفس الجواب. يعني انت لو جبت دلتا واي كانت طلعت معك دلتا واي equal to because y is upward delta y is negative تطلع minus mg times 1 second so بتطلع minus mg times delta y هي minus d sin alpha. Okay, since delta y is negative because y is positive up. So when you replace بالexpression of weight work of weight هو minus mg delta y, you will go back to the same result. And the work of weight is by replacing delta y by its value, the minus will cancel out and you will get that the work of the weight is plus mg times d sin alpha. يعني both methods the projection of weight on the line of motion أو minus mg delta y will give you the same result. Okay, هلا هيدي أهين عادة، هيدي is easier especially إذا عندك مثل هيدا البروبلم. يعني بالبروبلم اللي عم نعمله نحن هي منا straight line، عندك like this you have this so you have to the projection of the weight is varying وبدك تعمل integration So no need to go to the complex method. بمجرد ما أعرف delta y, I just use the easiest method, which is this one. Okay.
Okay, thank you.
Any other question? Okay. So we'll do now another problem. Second problem that I sent you. You have a 20 kilogram block pushed against a spring with negligible mass and force constant K equal to 400 Newton per meter, compressing it to 0.22 meters. When the block is released, it moves along a frictionless horizontal surface, and then it will move up a frictionless incline with a slope of 37 degrees, as shown in the figure. So I will draw the figure here. You have a spring attached to the wall. And now you don't attach the block to it. بنحط the block without attachment, and we compress the spring a distance d equal to 0.22 meters. Okay, now we leave this. This is the initial state. Okay, here after the compression, this is my initial state, and I will leave the block now. I will leave the block at 0.1. Okay, then this block will move on the surface, and then it will move on an inclined surface that is upward, like this. Okay, they told me that this is a frictionless surface. كلهم frictionless, so all surfaces are smooth, and the incline is characterized by a slope of 37 degrees. So this is 37. I want to find the speed of the block as it slides along the horizontal surface after having left the spring. So we need to compute the velocity just when leaving the spring. Okay, وعلى horizontal surface. حدا في يقول لي الفيلوسيتي حتتغير as I move on the horizontal surface؟
لا.
Why؟
ما في friction.
Yes, very good. على horizontal surface ما في friction، واصلا الويت والنورمال عندهم work شيء؟
لا العم perpendicular.
Okay, so the weight and the normal will not produce any work on the horizontal surface. Just إذا في friction it will, but they said that the surfaces are frictionless or smooth, so we don't have friction forces. So if I find the velocity just when leaving the spring, this velocity will be maintained constant until reaching the incline. Why when I move up the velocity will be reduced? شو حيصير when I move up?
الويت بيشتغل.
Exactly. لأنه kinetic energy will be transformed into gravitational potential energy. Okay, so how to get the velocity of the block when moving on the horizontal path? What should I do?
Conservation of mechanical energy.
Very good. I consider this is state 1, this is state 2. I apply conservation of mechanical energy between 1 and 2. What is the type of energy at point 1? Do I have a kinetic energy at 1?
No.
No. So kinetic energy at 1 is 0. Plus, what type of energy do I have at point 1? Do I have a gravitational potential energy?
No.
وين حتاخدوا الريفرنس للgravitational energy؟
And the horizontal.
Okay, so if I consider the horizontal line as my reference of gravitational potential energy, no GPE at the horizontal surface, it's 0. So I just have the elastic potential energy, and this elastic energy is equal to what?
Half K delta.
Half K the compression at 0.1 square. Okay, what is the value of compression? They gave me
0.22.
that the value of compression is 0.22, so times 0.22 square, and also they gave me the value of K, which is the stiffness of the spring in Newton meter. I replace it, equals to half times. And at state 2, what is the type of energy I have? Do I still have at state 2 inelastic energy?
لا
Why?
في
لأنه the block أول شيء when the spring becomes unstretched, why the block will leave it? ليش؟ عادة إذا عندي spring وبلوك بيروحوا مع بعض. Why here it will leave the spring?
لأنه الفيتاس تبعها frictionless surface.
لا، لأنه it's not attached to it. It's not attached to the block. يعني انتو لو في attachment بين البلوك والسبرينج، حتى بس اوصل لدلتا ال equal 0 شو بيصير؟ بتبلش التنشن، لأنه على الدلتا ال equal 0 على unstretched position حتكون الكمبريشن elastic energy تحولت لكايناتيك energy فعطت البلوك velocity v، وبما انه هو معلق بالسبرينج ساعتها it will stretch the spring. okay, and to find the maximum position reached بدي اعمل conservation of mechanical energy تشوف at what position okay بيرجع بيكمل السبرينج. حدا بيقول لي لو كان attached السبرينج للبلوك قد ايه حتكون التنشن لما الفيلوسيتي تصير 0؟
رح تكون ماكسيموم.
ايه بس قد ايه حتكون الفاليو تبعها؟
قد الأول بلس
Yes.
تبع البريزنتور.
لا، قد ال 0.22. You know why؟ لأنه أنا إذا compression أو tension تفرق الإلاستيك energy؟ ما بالنهاية أنا عم بعمل دلتا ال سكوير صح؟ يعني if you consider إنه أنا أول شيء عملت له compression، قد إيه كانت الانرجي هون؟ كانت half k دلتا ال compression سكوير صح؟ ما كان عندي elastic energy، ما كان عندي velocity، يعني الانرجي بس هي due to elastic potential energy. بس امرق بالunstretched position، بس ارجع اوصل لدلتا ال equal 0، شو بيكون صار؟ بيكون كل ال potential elastic energy تحولت ل kinetic energy، لانه at this point صارت دلتا ال 0، يعني ما بقى في potential elastic، بقى بس kinetic. هون عندي بس half mv square and I can find the velocity at this stage. هلا if the block is attached to the spring ما حيتركه، حيكمل ويجره معه، فحترجع تتحول هالkinetic energy ل elastic energy. and when v becomes 0 قد ايه لازم تكون هالenergy؟ equal لوات؟ للinitial energy، لانه no losses. يعني at this point I should have half k delta